Next is molecularity, which is denoted by capital letter M. What is molecularity? I hope all of you know that these are very basic things. Number of moles, atoms or ions participating in the reaction rate determining step. Okay. There are some key features, or you can say key points about the molecularity which we should know. First, it is a theoretical quantity. Second, it is associated with elementary reactions only. What is that? That we will discuss. It will be an integer only. Fourth, it cannot be negative, 0 or fractional value. And last, it will be 1, 2 or 3 only. Okay. So here for the reactions, having molecularity 1 are also known as unimolecular reactions. Molecular reactions with molecularity 2 are known as bimolecular reactions, and the reactions having molecularity 3 are known as trimolecular reactions. So let's talk about the molecularity. Molecularity represents the number of molecules, atoms or ions participating in the reaction rate determining step. It is a theoretical quantity. Means for any chemical reaction, if you know the RDS, if you know the rate determining step, then you don't need to perform any experiment, you can directly find out the molecularity. For example, for any reaction, let's say this is the RDS. If this is the RDS, this is the rate determining step, then molecularity will be, we can see that one molecule of A is participating with two molecules of B to form P. So molecularity will be 1 plus 2, that is 3. Okay. It is number of molecules, atoms or ions participating in the reaction. So it will be an integer only, that is a complete number. Obviously, it cannot be negative. Obvious hai that number of molecules cannot be negative. Number of molecules cannot be 0, because if 0 molecules are there, then reaction will not start. Okay, so we will not talk about the molecularity obviously, and it will not be a fractional value. Obviously, when any molecule is participating in the reaction, that complete molecule will participate. Half of the molecule will not. Okay, it is not like that because molecule can break into smaller molecules, but it cannot break in fractional numbers. Okay. Like the population of any country, population of any city cannot be in fractions. Population cannot be negative. Population cannot be zero. Similarly, molecularity, number of molecules which are participating in reaction cannot be negative, zero or fractional value. Now, what is the rate determining step? So, I hope all of you studied mass transfer, heat transfer in your BTech. So, there is a term flux we use, and normally flux defined as the driving force over resistance. And I hope all of you know that flux means rate per unit area. If we have heat flux, that will be heat transfer rate per unit area. If that is a mass flux, mass transfer rate per unit area, and so on. Okay. So ultimately you can see that rate is inversely proportional to resistance. So what is rate determining step? So just try to understand. Suppose we have a chemical reaction. A plus B gives something or anything. Any chemical reaction is there. If that chemical reaction occurs in more than one steps, okay. If any chemical reaction occurs in more than one step, then out of those steps, the step which have the highest resistance, because if resistance is high, then obviously you can see rate is inversely proportional to resistance. If resistance is high, then rate will be slow. So high resistance means slow rate. So any step out of those multiple steps, if any step has highest resistance, then that step will be the rate determining step, because that step, ultimately that step will control the overall process. Repeat, sir, the rate determining step. Suppose we have a chemical reaction like ammonia synthesis. N2 plus 3H2 gives 2NH3. So we know that whenever 1 mole of nitrogen will come in contact with 3 moles of hydrogen, they will form 2 moles of ammonia. That is a normal reaction, overall reaction, we know that. But if we go in the mechanism of that reaction, and if you find that that reaction is occurring in multiple steps, let's say 3 steps. For example, just imagine we have a reaction N2 plus 3H2 gives 2NH3. Let's say that reaction is taking place as N2 plus H2 gives 2NH. 2NH plus H2 gives 2NH2, and then 2NH2 plus H2 gives 2NH3. So this reaction is occurring in multiple steps, more than one steps. So out of these 3 steps, whichever step has the highest resistance, let's say this one, this is the slowest step. Slowest step means the rate is slow, and if rate is slow, the resistance will be high. So the step with the highest resistance will be the rate determining step. Okay. And in that rate determining step, if you see, 2 moles of NH reacts with 1 mole of H2 to give this. So this is the RDS. So what will be the molecularity? It will not be 1 plus 3 equal to 4. No. Molecularity is always defined for the rate determining step. Moles, atoms participating in RDS. So in this RDS, 2 plus 1, 3 moles are participating. So what will be the molecularity of the reaction? 3. Okay. So this is the molecularity. And suppose if this first step is the RDS, let's say, if first step is the RDS, then what will be the molecularity? 1 plus 1, 2. Okay. So I hope now you can define RDS. In generic term, in layman terms, we can say RDS is the slowest step. But technically, the slowest step means the step with highest resistance. How will we calculate the resistance? We don't calculate the resistance. We cannot calculate the resistance like this. Okay. We will find out the rate only. We will calculate the rate. We will measure the rate of the steps. Okay. In every step, we will measure the rate, and with the help of rate, we can find out the resistance, because resistance will be inversely proportional to rate. That's why in layman terms we define this with the help of rate only. The slowest step is the RDS. But why? Because that step has the highest resistance. Okay. Now, molecularity will be 1, 2 or 3 only. Why? We have so many reasons for that. Okay. Mainly there are two explanations, and you can use any one of them depending on the quality of the interview. Okay. If gossips are going on in the interviews, then you can simply say, molecularity of any reaction will be 1, 2 or 3 only. Why? Because in science, we believe only on those things which are factual, which exist in real life. Okay. And till now, in the entire universe, till now, we have not found any reaction with molecularity greater than 3. So that's why we say, for any chemical reaction, molecularity will be 1, 2 or 3 only. Okay. And if that is a pure technical interview, like for Bhabha Atomic Research Center, ISRO, DRDO, NPCIL or any other profile, then you can simply answer why molecularity is 1, 2 or 3 only. Because based on the collision theory, the probability of more than 3 molecules to have the simultaneous collision is 0. Means at any point, suppose this is the point, at this point, maximum to maximum, only 3 molecules can have the simultaneous collision. If we have more than 3 molecules, then those, let's say 4, 5 or 6, whatever it is, if we have even 4 molecules, then those 4 molecules cannot have a simultaneous collision over a single point. Simultaneous collision means, let's say if I talk about these 3 molecules, so at this point, if this is a point, at this point these 3 molecules are having simultaneous collision, means all these 3 molecules are in contact with each other simultaneously. All 3 molecules are touching each other, are in contact with each other. They are interacting with each other at a single point. So that is the collision theory. And if we have more than 3 molecules, like 4, 5, 6, 7, 8, 10, 100, 99, whatever it is, okay, then if even 4th molecule is there, then 4th molecule has to wait, because all 4 molecules cannot come in contact with each other over a single point simultaneously. That's why the probability of more than 3 molecules to have simultaneous collision is 0. So that is the reason. Since more than 3 molecules cannot have the simultaneous collision, so it means more than 3 molecules cannot participate in the reaction simultaneously. That's why we say molecularity of any reaction cannot be more than 3. It will be 1, 2 or 3 only. I hope it is clear to all of you. And it is associated with elementary reaction. Why? What is the meaning? It means based on the number of steps. We will discuss this after this part. Based on the number of steps, any chemical reaction can be classified into two categories: elementary reactions and non-elementary reactions. Okay, so a molecularity is associated with elementary reactions only. Means we define the molecularity, we calculate the molecularity only for elementary reactions, not for the non-elementary reactions. Okay, we will see that thing as well. Why we don't talk about the molecularity for non-elementary reaction. So next is order of reaction. Basically, order of reaction means, if someone asks you, how can we explain the molecularity of unimolecular reaction according to collision theory? Collision theory fails for the unimolecular reaction, as you can understand, Diksha, because unimolecular reaction means only one molecule is participating in the reaction, and if only one molecule is there, then obviously it cannot have the collision. For the collision, we need at least two entities, two objects, two molecules. So for unimolecular reactions, we can say that only one molecule is participating. It means that one molecule, either it is being decomposed or dissociate in some smaller or other molecules. Okay? Is it clear? I hope it is clear. Next is order of reaction. So what is order of reaction? What is the significance of order of reaction? So for any chemical reaction, order of reaction signifies how the concentration will affect the rate of reaction. Means, if we go with the definition of overall order of reaction, so overall order of reaction may be defined as the sum of exponent terms, that is powers, of concentration in rate equation, that means rate law. Okay, so suppose for a chemical reaction we have the rate equation R is equal to K Ca power alpha Cb power beta. So overall order of reaction, which is denoted by small n, remember this, capital N is used to define number of moles, small n is used to define overall order of reaction, that will be sum of powers of concentration terms, that means alpha plus beta, that is overall order of the reaction. What is alpha? Alpha is the apparent order of A, beta is the apparent order of B. Okay, now what is the meaning of order of reaction? What is the significance? Let's try to understand. Suppose for any chemical reaction we have rate equation R is equal to K Ca power N. We know that K is the rate constant, which is the function of temperature only. If you draw a curve between R versus Ca, okay, suppose if order of reaction is 0, then R will be equal to K. K is the function of temperature. If temperature is fixed, K will be fixed. So R will be like this for order of reaction 0. Okay, means independent of concentration. If order of reaction is 1, then R will be equal to KCA. R equal to KCA means Y equal to mx, a straight line equation passing from the origin, that is n equal to 1. Means rate of reaction varies linearly with concentration. If concentration decreases, then rate of reaction will also decrease linearly. Okay. Then if order of reaction is 2, R is equal to KCA square. Y equal to mx square means parabolic equation. So it will be a parabolic like this and so on. For 3 it will be cubic. Okay. So how the concentration affecting the rate of reaction. Okay. That is the significance of order of reaction. So for any chemical reaction, suppose we have R equal to KCA CB square. It means, just try to understand, overall order is 3. Okay. So if you increase the concentration of A, if you change the concentration of A from Ca to 2Ca, means if you double the concentration of A, then rate of reaction will be doubled, as Ca power is 1. R is changing linearly with A. Okay. And if you change the concentration of B to Cb, if you change the concentration of B to Cb, means if you double the concentration of B, then since it is power 2, so rate will be quadrupled, means 4 times. Okay. So this is the apparent order of B. That is the meaning of apparent orders. Means when we talk about the order of individual reactants and combinedly 1 plus 2, 3, that is overall order of the reaction. So I hope it is clear to all of you what is the significance of order of reaction. It helps us to identify how the concentration is affecting the rate of reaction. Okay. Now if I talk about the key features, so it is an experimental quantity. It can be an integer. It can be negative, 0 or fractional value. If you want to write the examples, then I am writing few examples. Further you can add n number of examples by yourself, like photosynthesis reaction. What is photosynthesis reaction? Reaction between CO2 and water. So CO2 reacts with water in the presence of light to produce oxygen and glucose. What is glucose? C6H12O6 and oxygen. So this is the photosynthesis reaction when you balance it. The photosynthesis reaction is the example of zeroth order reaction. Okay. Second, radioactive decay. Most of the radioactive decompositions follows first order kinetics. Third, burning of carbon monoxide. So burning of carbon monoxide rate is proportional to concentration of CO power -1. Means that is the example of -1 order of reaction. And last, decomposition of acetaldehyde, that is CH3CHO decomposes to CH4 plus CO. Here order of reaction is 3/2. So order of reaction can be 0, can be positive, integer, can be negative, can be fractional value. And why order of reaction can be 0, negative, fractional value, that we will discuss. So guys, I have a question for all of you. Try to figure out the answer, and if you found any difficulty, then we can discuss that in the next class. What is the question? Question of the day. Yesterday I gave you one question about the phase. Today the question is, कौन सा क्वेश्चन है? CRE की बात करते हैं अभी. In my BARC interview, the panel asked me one question: what is order of reaction? That is very easy. I answered that. After that, they asked me to write one example of second order reaction. That is also simple, I think. I did that as well. But after that, they asked me, can you tell us, for this second order reaction or for any higher order reaction, how can we reduce the order of reaction if it is possible? And if it is not possible, then why? Okay, so I am giving you the same question. Give me the answer in next class, because I have the time machine. With that time machine, I will go in past and I will answer that question. Just thanks to you. Okay, so I am giving you this question and answer me next time. For any higher order reaction, means greater than 1. For any chemical reaction having order greater than 1, can we reduce the order of reaction? If yes, then how? If no, then why? Okay? Have you got the question? Question समझ में आया? कुछ तो बोलो, yes, no. Okay. So please guys, help me with the answer in next class, so that I can use my time machine and I can go in past and I can answer this in my interview. Okay, so till then, move to this. Let's talk about this part. And if you can answer this question, then you will get to know by yourself why photosynthesis reaction is zeroth order reaction. Yes, okay, wonderful. So next thing is chemical reaction. So we can classify the chemical reaction based on number of steps into two categories. One is elementary reaction. Second is non-elementary reaction. So as the name suggests, elementary reaction, sorry, name doesn't suggest here, you just need to memorize this. Okay, elementary reaction which occurs in single step, that is one step. Non-elementary reaction which occurs in more than one step. Okay, that's it. That is the meaning of elementary and non-elementary reaction. Now let's talk about their characteristics. So suppose we have a chemical reaction, A plus BB gives P. First part of our favorite reaction. A plus BB gives P. If this is an elementary reaction, then obviously it will occur in one step. And what will be that step? That step will be same as the reaction. That is A plus BB gives P. If this is a non-elementary reaction, then it will occur in multiple steps, more than one, maybe 2, 3, 4, 5 and infinite steps. It can be anything depending on the reaction mechanism. So let's say this reaction is occurring in 3 steps. Suppose A by 2 times of A plus B times of B gives C star. C star plus A by 3 times of A gives Cp, and further Cp plus A by 6 times of A gives P. Okay, so let's say these are the 3 steps. So this is a non-elementary reaction, and if this is a non-elementary reaction, out of these 3 steps, suppose this is the slowest step with highest resistance, so this will be the RDS. This will be the rate determining step for me. But when I talk about the elementary reaction which occurs in one step only, so since it has only one step, so by default that one step will be the RDS, without any doubt. Okay, and we know that from the power law which we discussed today in the morning. Rate equation is always written only for the rate determining step. Okay, so for this reaction, since this is the RDS, what will be the rate equation? R will be equal to K, concentration of reactants, that is A and B, power alpha and beta. And from the power law, we also know that the value of apparent order alpha I is same as their stoichiometric coefficient in RDS. Not in the reaction, but in the RDS. So here in the RDS, alpha is equal to A, beta is equal to B. So overall order will be alpha plus beta, that is A plus B. So for elementary reaction, one thing is confirmed, that the apparent order of the reactants are same as their stoichiometric coefficient in the reaction. Apparent order of the reactants are same as their stoichiometric coefficient in the reaction. Okay. And one more thing, what is the, since it is an elementary reaction, so we can also talk about the molecularity. So what will be the molecularity, guys? For this elementary reaction, what will be the molecularity? बोलो, क्या होगी molecularity? Order is equal to m. क्या बोल रहा है ये आदमी? मैं भी टाइप करते हुए गलती से एंटर हो गया. Overall order is equal to m. Overall order is n, bro. Order of reaction defined by small n, not m. Small m is nothing. In CRE small m का कोई मीनिंग नहीं है. Guys, tell me what will be the molecularity for this elementary reaction? M is equal to A plus B. N is equal to molecularity A plus B. Wonderful, guys. Molecularity will be A plus B, as we can see that A unit of A reacts with B unit of B to give product. So molecularity will be A plus B. It means for elementary reaction the molecularity and the order of reactions are same. So tell me one thing, for elementary reaction, if overall order and molecularity is same, then can I say for elementary reactions, as molecularity will be 1, 2 or 3 only, so for elementary reactions the overall order cannot be 0, cannot be negative, cannot be fraction, and it will be 1, 2 or 3 only. Is it clear to all of you? For elementary reaction, as the molecularity and overall order is same and molecularity cannot be 0, negative or fractional value, it will be 1, 2 or 3 only. So similarly for overall order for elementary reaction, the overall order cannot be 0, cannot be fraction, cannot be negative, it will be 1, 2 or 3 only. So remember this thing. So it means if you want to identify whether the given reaction is elementary or not, we have one idea. Okay, obviously we cannot identify every reaction, but at least we can identify some of the reactions, that whether these reactions are elementary or non-elementary. For example, if I talk about water synthesis, S2 plus O2 gives H2O. Here you can see 1 plus 1, 0.5, 1.5. Order of reaction, molecularity cannot be fraction. So obviously this is non-elementary reaction. Ammonia synthesis, N2 plus 3S2 gives 2NS3. 1 plus 3, 4. Molecularity cannot be 4. So definitely this is also a non-elementary reaction. Photosynthesis reaction, 6CO2 plus 6H2O gives whatever it is. 6 plus 6, 12. Molecularity cannot be 12. So it's obvious this is a non-elementary reaction. Okay. But if I talk about H2 plus I2 gives 2HI, then 1 plus 1, 2. Now I don't know. It may be elementary or may not be. But one thing is certain, this kind of reactions are definitely not the elementary one. These are non-elementary reactions. Like CO plus half O2 gives CO2. Again 1.5, molecularity cannot be fraction. So definitely this is also not an elementary reaction. This is non-elementary. This is non-elementary, this is non-elementary, this is non-elementary. But this one, H2 plus I2 gives 2HI, may or may not be. That depends. So that's how we can identify, at least up to some extent, whether this is a elementary or non-elementary reaction. Okay, and let me give you one basic idea. Remember this for your entire life, at least for you till the GATE exam and interviews. For us, every given chemical reaction in exam or in interview, if anyone give you any chemical reaction, or if you have any numerical related to CRE, in which chemical reaction is there. So for us, all the given chemical reactions are non-elementary. Okay, we will consider the given reaction elementary only and only when it is mentioned. If they say in the statement, this is an elementary reaction, this is a single step reaction, only then we will consider that as elementary one. Otherwise for us, all the chemical reactions are non-elementary. And for any elementary reaction, overall order will be 1, 2 or 3 only. It cannot be 0, negative, fraction or greater than 3. Okay. So this is something about the elementary reaction. Now let's move to the non-elementary one. For non-elementary reactions which are occurring in more than one step. Now just try to understand. For molecularity, we wrote the first point, it is a theoretical quantity. And second point was, it is associated with elementary reactions only. Now I hope you can understand why. Because if reaction is occurring in more than one step, then to identify the RDS, to identify the reaction mechanism, you have to perform the experiments. And after performing the experiments only, we can identify the reaction mechanism. And when we have the reaction mechanism, only then we will be able to identify the rate determining step. Okay, but molecularity is a theoretical quantity. So that's why it is associated with elementary reactions only. Because for elementary reactions, to identify the RDS, we don't need to perform any experiment, as they occur only in one step. So for non-elementary reaction, suppose if this step is the RDS, if this is the rate determining step, then what will be the rate equation? So R will be equal to K, concentration of reactants, and here remember rate equation is always written only for the RDS as per the power law. So for this RDS, reactants are A and B. So K, concentration of A power alpha, concentration of B power beta. Overall orders are alpha plus beta. And what is the value of alpha? According to power law, apparent orders will be same as their stoichiometric coefficient in the RDS, not in the reaction. So in RDS, alpha is equal to A by 2 and beta is equal to B. And here you can see that for component B, apparent order is same as their stoichiometric coefficient in the reaction. For component A, it is different. So for non-elementary reactions, apparent order of the components may or may not be same as their stoichiometric coefficient in the reaction. For elementary reaction, apparent order of the components will be same as their stoichiometric coefficient in the reaction, 100%. But for non-elementary reaction, may or may not be. That depends on the reaction kinetics. Like for the reaction S2 plus I2 gives 2HI. Suppose rate equation is given like this. In any exam or in any problem, for this chemical reaction, rate equation is given like this. We can see apparent order are same as their stoichiometric coefficient. But still, we cannot say this is elementary or non-elementary reaction. Basically, we cannot say this is elementary reaction. Because for elementary reactions, apparent orders will be same as their stoichiometric coefficient always. But for non-elementary reactions, may or may not be. It may happen that these are the same as this for non-elementary as well. So still we cannot say this is elementary one, just based on the order, just based on the reaction rate equation. Okay. So remember this, for non-elementary, they can be same, they can be different. Okay. So for us, every chemical reaction is non-elementary reaction. We will consider any reaction to be elementary only and only if it is given. Otherwise, that is non-elementary for sure. So I hope it is clear to all of you. This is something about the elementary and non-elementary reactions. Now the question is, why in this world the order of reaction can be zero, negative, fraction? Why? Is it clear to all of you that if apparent orders are same as their stoichiometric coefficient, then still we are not sure that is elementary or non-elementary. We will consider that as non-elementary only. Okay. Yes, okay, wonderful. So now, why the order of reaction can be negative, zero or fractional value? That depends. Like, have you noted all this part? Can I erase it? तुम तो नोट ही नहीं कर रहे, तुमसे क्या पूछना, स्पेशल मानुष हो तुम. Suppose this is the RDS. Let's say for this chemical reaction, this is the RDS. So here, what will be the rate equation? R will be equal to K, concentration of C star power 1, obviously apparent order will be same as their stoichiometric coefficient in the RDS, and concentration of A power A by 3. This is the rate equation. Okay. Now what is C star here? So if you see, A and B are the reactants, means our input. So we can control the inputs. Okay, if we want to maximize the output, we have to optimize our inputs as well. Okay, so we can control the values of our input A and B. But if you see C star, Cp, so these the components which formed during the reaction and disappeared during the reactions only, which formed and disappeared during the reactions. Okay, those are intermediate components, intermediate products. So here C star is some intermediate component, intermediate complex, intermediate product. So obviously we don't have any control over this. We can control the inputs only, but we cannot control this. So what we have to do? We have to eliminate the C star in terms of Ca and Cb. So if you want to eliminate C star in terms of Ca and Cb, then you can use n number of methods, and the most popular method is pseudo steady state approximation. That is in your BTech syllabus, but unfortunately now this is not in your GATE syllabus. It was there in your GATE syllabus till 2014, but when in 2015 syllabus was revised, after that this is not in your syllabus. So we will not talk about this method. Okay, so this is one correlation, one algorithm, you can say, one approximation method, you can say, to replace the concentration of intermediate complex, intermediate products in terms of Ca and Cb. And after solving this and using and all, doing something based on this or some other methods, if your rate of reaction is coming out to be like K1 Ca Cb over 1 plus K2 Ca square. For example, it is coming out to be like this: K1 Ca Cb over 1 plus K2 Ca square. Then, can you tell me what is the order of this reaction? No, we can't say. So this kind of reactions, and remember now guys, any chemical reaction in which rate equation is like this, those reactions are known as mixed order reaction. Okay, why mixed order reaction? Because their order changes depending on the reaction conditions. How? Suppose if concentration of A is low, if Ca is low, and if Ca is low, then obviously 1 plus K2 Ca square can be written as 1, because if Ca is low, Ca square will be smaller. So 1 plus K2 Ca square can be written as 1 as well only. So R will become K1 Ca Cb. So in this case, what is the order of reaction? You can see 2. In this case, the order of reaction is 2. Second case, if concentration of A is high, then 1 plus K2 Ca square can be written as K2 Ca square, because if Ca is high, Ca square will be higher. So 1 plus K2 Ca square can be written as K2 Ca square. So your rate will become K1 Ca Cb over K2, क्या लिख दिया मैंने, K1 Ca Cb over 1 नहीं आएगा, K2 Ca square, that is K1 by K2 Ca power minus 1 Cb power plus 1, that is overall order is 0. Let me write this case here. If Ca is high, then obviously 1 plus K2 Ca square can be written as K2 Ca square. In this case, rate of reaction will become K1 over K2 Ca Cb over Ca square, that is K1 over K2 Ca power minus 1 Cb power plus 1. Okay, so you can see apparent order of A is minus 1. So reaction is negative order in terms of A. Apparent order of B is plus 1. So reaction is first order in terms of B, and overall order is 0. So when Ca was low, overall order is 2. When Ca is high, overall order is 0. Okay, so that is mixed order reaction, where order of the reaction changes based on the reaction conditions, based on the feed composition. Okay, and that is the reason why order of reaction can be negative, fraction or 0. Time हो गया. So guys, this is all about the basic terminologies in the CRE, elementary and non-elementary reactions, molecularity, order of reaction, etc. Next time we will discuss about the rate constant K, how to calculate rate constant K, the units, the theories involved there like Arrhenius law, collision theory, transition state theory. Okay, and if after that we have some time, then we will also discuss about the methods to calculate order of reaction. Okay. So for now we will upload, I will share the assignment 1 with all of you. Some very basic questions are there, 15-20 questions are there, 25 I think, very basic questions. Okay, to practice all these things once again, and you can get the assignment in the same lecture. Okay, means when you log in on this portal and you see the CRE part, CRE module, so in the same lecture the assignment will be attached. Okay, after 1 or 2 hours. So till evening you can check that. Otherwise, if you have any issue related to that, then you can contact to Lalaji. His number was given to you in the Zoom meeting yesterday. And all of other people also have the same thing. So assignment 1 is, I will attach, and otherwise you can contact on to the office number. They will share the assignment over the WhatsApp as well. Okay, on your respective WhatsApp groups, agar bana hai to, if there is any group. So see you guys. So in next class, if we have some time, so no, not in the next class, we will discuss that assignment 1 in the Tuesday, on the Tuesday or Wednesday. So have a happy weekend and check your schedule for the Monday, because maybe from the Monday your new one more subject is going to start, maybe. Okay. So want CA in numerator get changed according to the cases. Pradeep, CA in the numerator will, how will you change that? If CA is high or low, still it will be in the product. If that term is in addition, only then we can do that na, like 1 plus 100 is equal to 101. 1 plus 100 is equal to 101, or you can write it as 100 only. 1 plus 0.01 means 1 plus 0.01 means 1.001, or you can write it as 1. Okay, if that is in numerator, it will change or not? Here it will not change, but how the concentration affects the numerator value, that we will discuss when you will give me the answer of my question. Okay, the answer of this question is also hidden in that one. Can we change the order of reaction? If yes, then how? If no, then why? Okay, so see you guys on the Monday, and check your schedule for the Monday as well, because maybe your new subject may start from the Monday or otherwise from the Tuesday. Okay, so have a happy weekend. Thank you. Thank you, sir. वेलकम. अरे यार, क्या स्टार्ट कैसे होता है, ये बंद कैसे होता है? वैसे बंद